Okay, so guys, good afternoon, uh, and welcome to the online class. And today we are going to talk about the fundamentals of the networking. Okay, so let me share my screen quickly. Okay, so now I'm putting everyone on mute. So if you want to talk, then you can unmute yourself and talk. Okay, so computer network. See, in the last class, what we discussed that was all about a summary, right? Um, it was a teaser of the networking. Okay, but now today we are going to talk actual. We'll go bit by bit and we'll try to cover all the fundamentals. So by end of this class, we'll make sure that you understand all the basic fundamentals of the networking. Okay, so let's start. Um, okay, so networking. So networking start from two computers. Okay, so if you have one computer, okay, and if you have another computer, you want to share the data, you want to share like if you have one printer, three systems, so you need to connect the print one by one to each system. So instead of that, if you do the networking, so you will be able to take up that print can be shared, and everyone, all three machines can be take a print from there. So what is computer network? The simple answer is connecting two or more than two computers for what? For sharing hardware and the software. Okay, so if suppose there is one common file in this server, okay, that can be shared to all these machines. If this is a common printer, that can every machine can take a print from this print. There is a common internet, every machine can go and access the internet. Okay, so that is the computer network. Okay, so what happened? Please don't talk. Okay, fine. So uh, this is all about the computer network. So a computer network can be two computers. Okay, it should start from the two computers, connecting two computers to thousand and lakhs of the computer. Okay, so now we understand the networking. The use of networking is sharing the data, hardware shared or software shared. Okay, so with that, with the help of networking, you can achieve that. And the internet is the best example. So now networking should be having some classification, right? So there are three types of networks. Okay, actually, some more networks also came, so I will let you know that also. So the first is the LAN, local area network. So any networking within a building. Okay, any networking within a building. So this is called a LAN. Okay, within a same geographical location. So previously there was another like branch was MAN, so metropolitan area network. So what MAN was, the MAN was like the local ISP. They used to install a tower in each building. Okay, and it was very costly solution. But when WAN technology came, so WAN actually replaced the MAN. So now you can say LAN and WAN only. So there is no one is using the MAN. Okay, so what is LAN? So local area network within an office, like you can see all these machine, all this server, printer, internet, they connected into the same switch via cable. Okay, so we can build a LAN, local area network. Okay, similarly, as I said, the MAN, metropolitan area network, was like if you have a one office in in Mehdipatnam, another office in High Tech City. So you want to you want to share the data between these two offices. So that time, ISP, they used to install one tower at Mehdipatnam office, another tower at your High Tech City office, and they used to charge very huge. It was very costly solution. Okay. And but when WAN came, wide area network, so sorry, it replaced the man. So now no one is using man. So now only two things, LAN and the WAN. So now what is WAN? WAN is nothing but connecting multiple LAN. So I can say LAN plus LAN is equal to WAN. Okay. See, let's say you have one office in Hyderabad, another office in Dubai, another office in UAE, Saudi, and another office in USA. Okay, so you want to connect them. So you need to use a router there. Okay, you need to take a help of ISP. Okay, so ISP is a internet service provider. So ISP, they provide two type of connectivity. The one is called internet. Internet is nothing but a browsing, which is called a public internet, right? So every machine you access the internet, browse Google or something. So that is internet. So that connectivity is provided by ISP. Similarly, when you connect your multiple offices, when you want to connect one branch to another branch, so that connectivity is called a WAN. Okay, also WAN. So that service also provided by the ISP only, internet service provider. So this connectivity called a private connectivity. Private means what? Private means only if if ISP provide a connectivity from this office to this office, so only they can talk to each other. Okay, and no other. This communication will be private. But when this office you are accessing the internet, that is called a public. So two connectivity, private connectivity and the public connectivity. So the ISP, they usually provide the WAN. In the WAN they use MPLS. So MPLS is multi-protocol label switching. So there is a separate technology for the MPLS. So how ISP connect your multiple branch offices, the study of that is called the WAN, learning the WAN technology. So that is something in the Cisco, there is a separate like a certification, the separate track. In the last lecture, I told you, right? There are various track of the Cisco, right? Routing, switching, wireless, data center, security. Similarly, there is one stream called service provider. In that, there will be a detailed study of the how the ISP work. So if you learn that and if you are expert in that, then you will be getting a job into the ISP who are actually managing this or providing this all MPLS or WAN technology or connecting your multiple offices. So at this stage, you just need to understand LAN and the WAN. WAN is nothing but, see, this is your one Hyderabad office, let's say, and this is your Dubai office, and you want to connect it. So we use a router. In last lecture, we had a basic information, right? So switch is used to build a LAN, right? So switch will have various port where you will connect your server, your machines, and all via the cable within an office. So you will switch help to build a LAN. But the router will have a less interface. So router used to build a WAN. Router used to connect your one LAN to another LAN. Okay, so that's what the router and the switch. So router and switch both are very important. So throughout this course, we'll learn how to access, how to configure the switch, how to configure the router and all. Okay, so that is LAN and WAN. Okay, so now before going into the WAN, so WAN is something in the WAN, like how you will connect multiple offices. Okay, this office to this office. So there are routing protocol will be used. So in that we have three methods: static routing, default routing, and the dynamic routing. So that we will see later. Okay, that is called a study of the routing, where where the router will get involved. Routing protocol will learn. But before that, we will learn the switching. See, before understanding the WAN, before building the WAN, we need to understand the LAN. Okay, so now we will not now we will focus on the LAN. First, we will see what are the things in the LAN. Okay, how to build the LAN. So that we are going to see. So now LAN. LAN is nothing but your one office, or you're within a building. If you have a 6 floors or 12 floors office, so all machines are connected to each other. Okay, so that is called a LAN. In the LAN again categorized into two types. Okay, peer-to-peer and the server client. peer-to-peer is something, in the last lecture we discussed, peer-to-peer is something, um, these all four machines are connected to a switch or hub. So hub is a previously it used, but now only we will have a switches. So all these machines will connect it to each other, and there will be no control. No control means this is called a work group networking. Work group means what? Work group means what? This all machines, and they will connect to via switches or via cable. They will connect to the switch, and there will be local users, like computer A will have a local user, computer B will have a local user, and every machine will have a local user. Okay, and anyone will do anything. There will be no control. Everyone can do anything. Okay, so that is the peer-to-peer. So the example is in your college labs, small institutes and also there will be a work. There will be called work group. So there will be no control. Anyone can do anything. Any machine can take print. Any machine can go to internet. There is no control over work group. Remember. So this is the first type. We will see. See throughout this course, you will be able to build a work group. Also, you will be able to build a server client. Okay. So now we are focusing on the LAN. Remember. Okay, LAN. So now the another thing is the another type of the LAN is server-based LAN, or it is also called client server network. So in that, what will happen to the switch? Here you have all the machines, A, B, C, D, E, F, whatever, all the machines. But with the same network, there will be server will get connected. Okay. So in the server, usually the Microsoft server operating system. Okay. So what is the difference between client machine and the server? So there is no only one difference is called operating system difference. Okay, this machine and the another difference is servers will usually will have a high-end hardware, like the RAM will be in more, processor will be more, or hard disk will be more. So that is the server. But in the client machine, it will be let's say this computer A. So computer A, so if you install Windows 11, so that is a client operating system. Okay. So, but in the same machine, you can install Windows Server 2019 or 2022. So if you install that server operating system, then that machine also become a server. That's the difference. So server is it is not something look like alien. It is the same. It is like a server only. It is the same. So in your lab, the machine itself, we will make a server. Okay, but ideally in the organization, server will be it will be having a more processor and it will be high-end hardware. Okay, so what is the advantage of server client? So all this client will be all this machine will become a client, and this is here on the server we will install Active Directory. Okay, Active Directory, and we will create the users on the server. So now what the advantage is, all these users will be created on the Active Directory. So all this machine will be the client of that server. So if you want to access, so you can just log in into this machine with your username. It will get authenticated from the server. Okay, then only you can log in into this machine. And with the same user ID, you can log in into any machine. There is no restriction, right? So there are a lot of control. So now we understand that server will control the all user traffic and all. So with the help of this, what will happen? So server will control all the users. Server will control who will access this file server. So there will be user profile. It will control, okay, this user A will um, can be only login between 9 a.m. to 6 p.m. After 6 p.m. user A cannot be login, right? That control can be happen on the Active Directory. Similarly, this user can take a print. This user can go to the internet. All these controls can be happen on the this one. So that's why the server is a part of networking. Remember, that's why we included a study of server in this course. So how to control this type of LAN with the server, that we are going to learn. You are going to learn throughout this course. So learning of the Microsoft server, how to manage these all clients from this server. So that is a separate study. Similarly, we will have a Linux server also. So Linux servers also very important in the LAN. Okay, they don't control, but Linux is mostly used for the automation, and a lot of applications will be built on the Linux based. Okay, so that's why Linux also very important in the LAN. So it is also connected into the LAN. So that's why we included the Linux also here. So just think about it. See, this is your course, computer hardware. Okay, understanding of the machine, software, application, everything. Then a study of the cable, study of the switch, study of the Windows server, study of the Linux server, and like this you will build a LAN. And once you build the LAN, to connect multiple LAN, you require a router. So study of the router also available, included in the course. So this is what you need to understand, what exactly you are learning. So this is what you are learning here. So now coming back to now after an LAN type, so now network topology. Okay, network topology means physical arrangement of the computer. So let's say you have multiple computers. Okay, like 15 computers. You want to build a LAN. How you are going to arrange them? So previously there were some topology like bus topology, mesh, tree, point-to-point ring. So this topology was there. So like the disadvantage of the bus topology was, let's see, all the machine was connected with a single cable. If this single cable break from here, the network will get destroyed. Similarly, in the ring, if the cable bring like cut down from here, so all this network will get disturbed. They will get isolated. Like similarly in the point to point also, if this machine want to talk to this machine, so they are dependent on this cable. If this cable breaks, so there will be no communication. Similarly the tree. So this was the these are the network topology. But so who is famous in the network topology and what we are using today? That is only one topology, that is called star topology. And what is star topology is? So star topology is, we use a central access device. So this is called a central access device. Like previously, switch hub was there, but now switch is there. So what will happen? All your computers via cable, they will connect to the switch ports. Okay. So this is called a star topology. What is the advantage? Advantage is, if this cable break, only this machine will isolated. Rest everything will work. If this cable break, only this machine will isolated. Rest all will work perfectly. And the another advantage of the switch is, uh, if you buy speed, see, if you buy a 1 gig switch port, okay, so every switch port, let's say switches are available from 8 port, 24 port, 48 port. So last is the 48 port switch available. After that there is no more. So you need to buy multiple switches. So 48 ports switch is the last one. So if you have a 48 port switch, so there will be option. So you want Ethernet port, or you want Giga Ethernet port, you want 10 gig Ethernet port, you want 40 gig Ethernet port. So these are the options available. So usually in the LAN, let's say 1 gig interface, 1 gig switch you purchase. So every port will have a 1 gig speed. Okay, 1 gigabyte speed. So when I talk about the bytes means, so let me open Notepad. So see, we have a bit, then we have a byte, then we have a megabyte, then gigabyte, then terabyte. Okay, like this. So what does it mean? Bit means one, zero or one. As you know, the computer understand zero and one. So bit will be in that. So byte means what? 8 bit is equal to 1 byte. Similarly, and okay, one thing I missed, kilobyte. So what is kilobyte? 1024 bytes are 1024 byte is equal to 1 KB. Similarly, 1024 KBs equal to 1 like 1 MB. Similarly, 1024 MB is equal to 1 gigabit. Similarly, 1024 gigabit is equal to 1 terabyte. So like this, the speed will be improved. So you can see here, if you purchase a kilobyte is not available, but megabyte. So if you purchase this, so usually you will get 100 Mbps speed. Very simple. 100 Mbps switch, if you purchase, so you will get 100 Mbps speed. If you take Ethernet port, so you will get the smallest one is 10 Mbps. 10 Mbps speed per port. 10 Mbps, 100 Mbps. Then after this, here you will have 1000 Mbps, 1000 Mbps speed, and here in the terabyte means here will be the 1000 gigabyte speed. Okay, I can say 10,000 Mbps per port. So see, if what it is your choice, which one you want. So nowadays this is the lowest one, but in the LAN usually you will find at least the minimum 100 Mbps speed of the switch port will be available. Okay, so every port will have this. So if you purchase gigabyte means you can say more speed. If you purchase terabyte, it will be more speed. So similarly, you have a 40 gig also available. You also have a 100 100 gig 100 TB also available. 40 TB, 100 TB. So like this many speed is available in the network. So speed is very important. So you just that's what I discussed this information, because you need to understand this. Okay, so now let's back to here. So this is what the star topology use. So if we use the 100 Mbps, so each machine will get a 100 Mbps speed, 1 gig speed, 1 TB speed. See, 1 TB, the moment you have a giga is fine, because the cable which we are using currently, we are using a copper cable, right? So copper cable also having the categories. So in the copper cable, okay, let me take notepad again. So in the LAN, we use cables. So, sorry, cables. Okay. So these cables will be two types of cable. We use, one is a copper cable, the another one we use fiber cable. So copper cable is generally used for the shortest distance, and fiber cable used for the longer distance. Okay. So copper cable, it support up to 1 gig speed. Okay. But the moment you want more speed, like 10 gig, so that time you need to use the fiber cable. Okay, so copper cable used for the smaller distance for the less speed, but this will be the easier. But fiber cable can give you more speed, and it will yeah, and it can connect to the longer distance for the LAN. But remember, the cost will be involved. Fiber optics will be very costly. Remember, that's the difference. Okay, and see, if suppose you purchase one 10 gig switch, 10 gig switch you purchase, and you want to connect your PC, but your PC is a Ethernet port. So PC cannot support the 10 gig. So what you need to do, you need to take all the high-end laptops, high-end PCs which support the 10 gig interface. That's what you need to spend a lot of amount. Okay, that's why in organization currently, the copper cable which is used, that is cat 6 is used. Cat 6 is category 6, so it provide 1 gig speed in the LAN. Every machine will have a 1 gig speed, so that's the minimum. But if you increase to the 10 gig, right, so it will be, you need to have all your endpoints, all your laptops, machines to be converted into the 10 gig. So that will be very costly. And I never saw any in my experience, and I don't see that all machines are 10 gig support. Okay, so usually, so this is the category 6 which support 1 gig speed. Okay, so that's you need to understand. So now let's go back. So start topology after that. Okay, so now I understand the LAN is important, right? For the LAN, I need like there are two types again, server base and work group. So now again in the work group, then again you have a topology. In the topology, we understand we are using the star topology. Now after the star topology, now let's build a LAN. So how to build a LAN? What are the things required? So to build a LAN, you need a computer or laptop with a NIC card. Then you need a power. You need a RJ45 connector. You need a copper cable, right? And you also need a central access device, switch or hub. So you can say switch. Switch is required. And one more thing, you need an IP address. IP address is a logical name provided by you, and the MAC address is a physical address provided by manufacturing company. So in the last class we discussed every PC in the networking, every PC it run with the two addresses. One is the MAC address, which is a physical, and another is the IP address, which is the logical. Okay, so now with this keeping in this information in the mind, let's build a LAN. Okay, so how to build a LAN? So there is one software we will use that is called packet tracer. Okay, so see, if suppose you want to build a LAN, so what you need to do is or you want to do the practice to build a LAN. So what you need, at least you need to purchase two to three systems. Okay, you need to purchase switch, PC switch, and you need to also purchase cables, right? And then you can build a LAN. So just to do this practice, you need to spend lakh of rupees for the LAN, how to build, just to build the LAN. So you no need to spend that much money, because your life got easy with this software. This is called Cisco Packet Tracer. Okay, throughout this course we will use this software. This is a simulation. It is look and feel um, say similar like a real time. Okay, so this is used for the practicing purpose. Okay, otherwise if you are rich people, then please purchase this and do the practice. I'm not a rich, I'm going to use the packet tracer. Okay, so now I will go and just use the packet. So how to install the packet tracer? So you just go on the Google, and today everyone whoever having the laptop, you should go and install the packet tracer. Okay, this is your primary task for today. So just go and download packet tracer. So whatever, see, actually the packet tracer, it was a software built by some network guys. So later on Cisco acquire that. So now it become a Cisco packet tracer. Okay, so generally like you need to have a login and all for that. So if I go here, uh, you just click on the third one, so you can see here. So currently 8.2.1 version is going on. So you will be having, so you just click on the download machine. So if you have a Linux machine or Mac OS, they also support, but we use a window, right? So you can take anything like 8.2 or anything. Okay, whatever the newest one. So once you install, so it will be like small utility. Just you need to click on it. It will look like this. Okay, so it will ask you for the authentication. Okay, so here there are two options, user login or guest login. So I'm going to access as a guest login. So it will take you to the some browser or something. Just minimize this, go back to the application. So now see, it is asking you to wait for a few seconds. See, I'm waiting for the guest login, 4 seconds, 3 seconds, 2, 1, confirm guest, done. Okay, so now can you see this? So this is a software we are going to use for our practice. So I connected with the guest. So now see, now this is offline. It is not online. So now it become offline. So now you can do the practice. Okay. So now how to do the practice? So in the left side, if you see here, so you have a network devices. So if you just click on it, end devices. So you will find you have a like a computer. You just click on it, just put it here. The PC is here. You want a laptop? Laptop is here. You want a server? Server is here. You want IP phone? IP phone is here. You want TV? Here. You want okay, wipe device? You can take this. You want a printer? See, printer is here. So can you see this? This all call end host. This all called endpoints. Even you want smart device, wireless device. It is here. See, all these endpoints are here. So now to connect them, you need a switch, right? So I'm going to take a switch. So I just click on here. So in the network device, you will find in the down, you will find the router, you will find a switch, you will also find a firewall. For the security, you will also find a firewall here. So even for the wireless devices, you will find these all wireless. Okay, so now I'm going to collect one switch. So here various switches are available: 2960 generic switch, then 3560 higher end switch is available. Similarly in the router you have a 1942 router, then 2901 series router, high end router also available. So now let's take a switch. So I will just take a switch, just put it just place it here. So I took a switch. So if you just go nearby, so your cursor, so it will tell you. So this is fast Ethernet interfaces are there, and can you see 1 to 24 total 24 ports are there on that switch. Okay, and there are two more ports giga you can see, so two higher port. If you want to see, just click on it and you can zoom in. So you will see it is the same like a real switch, Catalyst 2960. So it is having these ports. Okay, so you can just close it. So now uh, now you want to do the networking, right? So you need a cable. So where is the cable? So the cables are here, connections. If you just click on here, so you have a console cable, you have a straight cable, you have a crossover cable, you have even fiber cable also available. These all cables are available. So now I'm going to take a third one that is called a copper cable, which I use. So what I need to do, I need to just click on the machine, fast Ethernet 0 to the switch, first interface. Done. I will take another one from here to here, second port. From here, I'm connecting my server. Third port I'm connecting, right? Similarly, I will connect to printer. Fourth port I connected. Okay, so I don't need this one. So now that is just for the understanding I took. So just four machine we will connect. Okay, so see, you can see four different devices are. This is a PC, this is a laptop, this is a server, and this is the printer. Okay, and I want to be, see, this is the LAN. LAN means what? Connecting various devices for sharing the data, right? So this is called a physical connectivity. Okay, so you can see the green ports. So now see all ports are green now, right? So after this, what you need to do? You need an IP address. Okay, why? Because the MAC address will be already inbuilt into that. We will see how to see the MAC address. But first, I need to um, assign the IP address. So what you need to do, just go to the switch machine, just click on it. So just maximize and go to the desktop. And can you see it will look like how your real time machine look like? Say internet browsing, terminal, command prompt, IP address and all. So you want to see the MAC address of this PC? Just go to the run. Okay, and now you can say put the command ip config ip config space slash all. Please write down this command ip config space slash all. What it will tell you? It will tell you your physical address or MAC address of this machine. If I hit enter, so can you see I got the physical address? So this is how you will find the physical address of any machine. That is called a MAC address. See, physical address. Similarly, I will just minimize it. I want to see the MAC address of this laptop. Just go here, go to the desktop, go to command prompt, and just put the command ipconfig space slash all. Can you see the physical address, the MAC address? So what is MAC address? This is a 48-bit MAC address. So in another slide, I have the detail of the MAC address. I will show you. See, but this physical address will never ever change. Okay, because this is inbuilt. See, we haven't configured. It is came inbuilt. Every machine, every endpoint will have a MAC address. See, if I go to the server, in the server also you can find the same thing. Desktop, command prompt, ipconfig space slash all. See, this is the server MAC address 2286, the last digits. So these are the even for the printer also there will be MAC address, but you can see that like this. See, when you go to fast ethernet, so you will find, say, this is the MAC address. So if you compare, see what I'm going to do. Let me just collect all the machines. So this is my computer MAC address. I will just copy it. I will just place it here. So I will say this is my PC and this is the MAC address. Oh, sorry, it isn't copy. So I need to do like this, copy, and I will put it here. Okay, now next I have a laptop, right? So laptop MAC address, how to see? ipconfig space slash all. So I will just go to the laptop, command prompt, and I will just copy the MAC address. Why I'm copying this, I will show you. Because I want to show you that how switch will learn the MAC address. We will see, identify that. Then the server MAC address I want to see. So I will go to the server ipconfig, then I will just collect it. Guys, this is your first lab, okay? So after this class, I will post the lab in the group. So everyone has to do this lab, first lab. Server, this is a server MAC address, and printer, and this is the printer MAC address. Okay, so now you can see, and if you look at the pattern is same. See, all the MAC address patterns are almost same. Okay, so this is called MAC address. So now we need to assign an IP address. So what is IP address is? IP address is a logical IP address. Okay, so we will talk more about IP address later, but for now you can understand IP address means internet protocol address. There are two versions of IP address. One is the IPv4, which is a 32-bit IP address, and the second is IPv6. This is a 128-bit IP address. Okay, 32-bit. So now 32-bit, when I say 32-bit, so one of the example is something like this: 192.168.10.1. This is one of the IP address. So IP address is usually we use a decimal written into decimal format. So this is actually 1 octet. Then 1 octet means 8-bit, dot 8-bit, dot 8-bit, dot 8-bit. So like this, it become um 32-bit. See, 8-bit plus, or sorry. So there is another thing called subnet mask. So 8-bit to it represent 255.255.255.0. So this is one of the sample that this is how the IP address look like. Okay, so we will assign to every machine. So why we use this one, what is the IP address, so that detail will come later. But right now we decided that to the PC I'm going to assign 192.168.10.1. This IP address I'm going to assign. Then to the laptop I'm going to assign 192.168.10.2, because in this lab we are building LAN, basic LAN. 192.168.168.10.3, and to the printer I'm going to say 192.168.10.4. So see, this is a physical address and this is a logical address. Okay, the physical address assigned by the manufacturer company, and IP address assigned by you and me. Okay, so let's go and assign the IP address first. So I'm going to PC and just close this terminal and go to the IP configuration. So if you look at this, see, it look like the same how our real machine look like. There is a two options, static and the DSCP. So here I'm going to say IP address 192.168.10.1. And when you put a tab, automatically it will take the subnet mask. And there is one more thing, default gateway. We are going to talk about default gateway after few classes. Once we understand the L2, then we will go to the default gateway, third one. So right now we are not discussing about the default gateway. So one IP address is given, done. So now I will go to the laptop, and I'm going to assign the IP address to the laptop. 192.168.10.2. Done. Then to the server. Same server is same, look like a PC. So same IP address I'm going to provide. 192.168.10.3. Put a tab, automatically it will take a subnet mask. And the last one is printer. So to the printer, you can go to the fast Ethernet this place, and here you can provide the IP address 192.168.10.4. Just put a tab, automatically it will take. So done. So what we have done is we have given IP addresses. So I can just write down, you have option to write down here also. Like this machine IP address is 192.168 and all, you can say. PC, laptop, server, and printer. You connected physically, everything is working fine, and you also assign the IP addresses. Now what next? Now how to test? How to test here? Can I take a print from here, or can I take a print from here? So this all that is not possible here, but there is a one option called ping. Ping command is our bread and butter. Okay, so the first see, there are two commands. Commands are very important in the networking. The first command we learn is IP config space / all. We put it into the machine, right? So in the CMD, you need to go to the CMD of any machine, CMD, and apply this command. So you will find the MAC address. Similarly, ping is the one of the command. Ping destination IP. Ping destination IP. Destination IP means from any machine you can ping to another machine. Like you can from this PC, if you can ping to the printer. From this PC or from printer you can ping to the server. So we need to see the reachability. If the reply is coming, it means they all in the networking. They all into the network. That is the mean. So how to test that? Just go here, go to the PC, go to the command prompt. Okay, and here just say, see now, can you see this? Previously, when I put this command ip config/all, I just saw the physical address. But can you see the IP address was nothing there? It was 00. But now we assign the IP address. So now if I put the command again, so can you see? I saw the IP address now. This is the MAC address of the PC. This is the IP address of the PC. Now let me try to ping the printer from here. 192.168.10.4. Let's see what. Can you see the reply is coming? Reply from 192.168.10.10, and it is showing the 32 bits sent. It take 1 millisecond and the time to leave value is 128. It means the reply is coming means both have the reachability. Both can, this machine can take the print now. Similarly, can we try to ping the server? Yes, we are able to ping the server now. Can we try to ping to the laptop? Yes, we are able to ping to the laptop. Now all these four machines are connected to each other. Now from this server, let's go to the server, and from the server, let's try to take a print. Because in this virtual machine, we can't take a print, right? How you will see the print? But the ping command will help you to see the reachability. So from here, now see, to the server, if I see previous, there was no IP address. So after we assign the IP address, can you see the IP address came here? So ipconfig/all, this command will help you to see the MAC address and the IP address of that particular machine. So now from here, let's ping 192.168.10.4, which is our printer. Can you see the printer is able to, this server can take a print. Can this machine ping to the PC? Yes, I'm able to ping. The reply is coming from there. Can this machine able to ping the laptop? Yes, they are able to ping. It means we got a networking successfully. All these machines are able to reach to each other. In the meantime, these switches are smart switches. So now, if you notice one thing, so I will say on the switch port, this PC is connected on, uh, this PC is connected on fast Ethernet 0x1 port, right? Similarly, this laptop is connected on fast Ethernet 0x2, this port. Fast Ethernet 0x3 and fast Ethernet 0x4. So these machines are connected like this. So as I said, the switch is a smart device. Okay, there are two types of switches. So a manageable switch and the unmanageable switch. Unmanageable switches are plug and play. It will not have any brain. But the Cisco switches are the manageable switches, and they have the brain. The brain called cam table. How to see the cam table? Just go here, and here you just go to the CLI. So in the CLI, so can you see, just put a enter. So can you see you are into the switch now? And here I just need to put a one command, enable. Why we put this command? What is this greater than? Now it is showing hash. This all thing we will see in the next class. But now, for now, only one command I'm going to put here. Show MAC address table. What is the command? Show MAC address table on the switch. And the moment you hit, so can you see the same table I'm able to see? Now let's compare here. This is the notepad. One second. This is a notepad. And let's compare. See what our PC, which MAC address is 634D. Can you see the port 0634D? Can you see the MAC address? The port 4 where printer is connected. Printer MAC address is 892C. Can you see 892C port number 4? It means the switch has a brain. Switch is able to understand on my which port which MAC address is connected. Now you may thinking that where the IP address, why switch is not understanding the IP address. If you're thinking, then you're I can say you're smart. Good question, because these switches are layer 2 switches. They will understand. Now, what is layer 2? Coming back to the OSI layer. So layer 2 is within the MAC address. They understand only the MAC address. When we go to the layer 3, where the IP address will come, a router or layer 3 devices will understand the IP address. Switch, layer 2 switch will never understand the MAC IP address. Okay, so that again slowly we will talk about that. But now in the first lab, what you have done, you have built a LAN. See, all machines are able to ping to each other, and you also compare that the switch MAC address table, where the switch is understanding the MAC address. That's it. This is your first lab, which you have to do it today. Okay, so going back to a slide, so I will let you ask some questions. I hope everyone is understanding. Any questions? Active friendship. Okay, so no questions. Okay, let me ask the question. भाई class की can you unmute class का laptop? Yeah. Okay, now so which software we will use for the networking? Packet tracer, right? So how many types of addresses we use? MAC address. So you understand the lab one, how to build a LAN? Okay. So I want you to, before leaving the class, everyone should build a LAN. Okay, we have the packet tracer in the lab, so you just go there and do the practice. Okay, so before tomorrow's class, I want you to complete that class. Okay, that lab. So now, so that's fine. So let me go back to the screen share. You can mute. Let me mute it. Okay, I did it. Okay, so now let me share my screen back. Okay, now, so with this, it was a first lab where a simple LAN with the help of packet tracer we built, right? So understanding OSI and the TCP/IP. So this is very important theoretical stuff, but in the interview, see, the complete networking is run with these layers. Every layer has its own functionality, and every layer there are some device will work on that layer. Okay, so now OSI layer. So OSI, what is open system interconnection? It is it is a data model. Okay, it is a standard. Okay, why what was the need of this standard is, see, there are many organization, many manufacturing company, they uh, they build a laptop, they build a computers, right? Many countries like in India, various manufacturing company, in China, various manufacturing company, they build a laptop, they build a server, they build a net equipments, basically Ethernet they build. So all these machines, they need to connect to the internet. They need to connect to the somehow into the network. So if some another country, if there is no standard, anyone can do anything. Someone can try to like build a LAN port like a USB. Will it work? Will it connect to the switch? So this is how there should be some standard. That's why the OSI interconnect connection data model came. So they will follow this standard, and they will have a framework. Okay, so OSI layer is, there are total layers, 7 layer. So you can see the physical layer, data link layer, network layer, transport, session, presentation, and application. Okay, so the physical layer, is all our cabling will work here. Cables. Data link layer, it physical layer. So all on it understand the MAC address. So switch work on this data link layer. Then coming back to the network layer, so it understanding the IP address and the path determination. So router device is it work on the network layer. Then the transport layer, endpoint connection, reliability and all. So TCP and UDP it use two protocol, and the firewall layer 4 firewall will work here. So can you see physical data link? I can say cable, switch, router, firewall. And nowadays we have a layer 7 firewall also. But basically, like the below four layer 1, layer 2, layer 3, layer 4, networking team is responsible for this. Network team is responsible for it. And above layer, session, presentation, application, the application problem, application team will be responsible for that. Okay, now how the networking team is important, like responsible. Let's say one of the source, one of the machine is connected here, another machine is connected there, another server. The machine is unable to connect to the server. Okay, so there is a communication problem. So so when it come to you, if suppose the cable is broken from the server, so whose problem it is? Do they need to go and check the application? Do they need to go and check why the client is not connecting? No, because the physical connectivity should be first. Okay, then the switch will come, then the router will come, then the firewall will come. This is how the network will work. Okay, so the complete networking is on this OSI model. Okay, so just a second. Okay, so OSI layer, so physical layer, data link layer, network layer, transport layer, session. So like this 7 layers are there. So I will share you, so you can go through with more detail for each layer. So because this is not a much theory class, but uh, the understanding of the physical layer, what physical layer does. Okay, so now see, this is one of the best example. Okay, so on your machine, when you access the Google, so all these 7 layer will work. How? Okay, so the first thing on the physical layer, your let's say your PC is not connected with the LAN. Will it browse the internet? No, it will not browse the internet. That's why the physical layer is important. If the switch port is not enabled, then and the switch is not understanding learning the MAC address, it will not browse the internet. That's why this MAC address and learning is very important. If um, you don't have an IP address and the network, so it will never hit to the Google. So like this, every layer is important here. Physical, data, network, transport, and finally the session, presentation, application. Then finally on your machine, you will find the Google. Okay, so cable, MAC, IP, and the firewall. So like this, four things are the networking. Networking dependent on the cables, networking dependent on the switching, networking dependent on the routing, and the firewall. So all these 4 layers we are responsible. So if you have a clear understanding of this, you will become a excellent network engineer. Okay, who have this understanding, troubleshooting understanding. Okay, why the source and destination is not working means you need to find what is the problem, where is the problem. The problem is in the cabling, problem is the switch, problem in the router, or problem in the firewall. So like these layers are there one by one, one by one. So we will see, and my pattern of understanding also the same. First, you should understand the physical, you should understand the network switch, then understand the router and the firewall. Like this, you will go up by. So in the first class, directly, I cannot show you the router because you don't know the cable now. You don't know the switch now. That's why you need this one. So similarly, the another model came that is called TCP/IP model. So what they did is, instead of 7 layer, they made it into the 4 layer. Okay, so the down physical and data link layer club into the network layer. then network layer become internet layer, transport is the same, and the top three layer, session, presentation, application, that become application layer. So that is still fine. So it's just naming convention, but you can see the physical data link layer, network, and transport. So physical is the cable, data link the switches, then the network and the transport layer where the firewalls will come into picture, the communication will come into picture, and finally the applications will be there. So we are not building this application. The another team, the programmers and all, they build the applications. We but applications have the dependency of the network. That's why in every organization, the first thing will be, you remember in the last class what I said, the data center planning, designing, racking, stacking, cabling, labeling, rack mounting, designing of the rack, network rack, power, cooling. These all things are in the data center. Then we build a LAN. Then the LAN, from the LAN, the cables will get terminated to the switches. Then the switching will come into picture. Then the routing will come into picture. Then the firewall. And once it is set up, on top of that, wireless will work. On top of that, video will work. On top of that, security will work. Right? So these are the fundamentals. Okay. So this is how it works. See, if you want a communication between this machine to this machine, then the cable should be connected. Then the MAC should be learned from the both machine. IP address should be learned from both machine. Then the connection will get established, and they will able to communicate to each other, right? So now we understand that physical layer, data link layer, and then so this will be our study pattern. So first we will try to understand the physical layer. In the physical layer, there is not much lab. Only one thing, we need to understand the physical layer. What exactly the physical? In the networking, if you go to any laptop, any machine, so there will be a NIC card. Previously, you need to buy a NIC card, but nowadays it will be inbuilt, attached to the motherboard. So you will have a NIC card where the LAN port will get connected. See, this is the copper port, and this is called a RJ45 connector. It will get connected to this one. This is one of the example where this blue cable is connected. If this blue cable is not connected, means your machine is not into the network. That's why the primary thing is your network cabling. Okay. See, we no need to become a cabling expert, but we should have an understanding of what are the types of cables and all. Okay. So there are many types of cables. Okay, like coaxial cable, twisted fiber optic cable, unshielded cable. So can you see they have a different look, different type and all. So if you want to become a cable expert, so there is a books written onto that. Okay, no one is okay. Can you see the example I'm giving you? The coaxial cable, the data like it will covered by the outer layer. It will have some thickness. Then with the aluminum wire it will connect it, then another third layer, and after that the fourth will. So jacket, these are called the jackets and all. So do you think in the interview they will ask you what is the thickness of the second cover in the coaxial cable? If you want, definitely you can go and read the books of the cabling. So that's what here, try to learn that which is really see, no doubt every learning is important. Okay, but uh, um, going this much deeper dive, like thickness of the cable and the outer and inner layer, that doesn't make sense, right? Instead of that, you should go dive and deeper into the technology, because these cables you are going to purchase it, right? You just buy it. So that's my understanding. But if someone wants, someone can be disagree. But this is what I never ask. I conduct a lot of interviews. I never ask, can you tell me what is the coaxial cable thickness of the aluminum cover? So that doesn't make a sense. But this lab is you are going to do. The copper cable is important because copper cable we are going to use into the LAN. So copper cable will have, when you open the copper cable, there will be 8 cables, 8 wires will be there. orange, white, orange, green, green, or green, white, blue, blue, white, and the brown, brown, white. So these 8 cables you need to um, connect it properly, and you need to use RJ45, that is called, which is called a jack, and you, with the crimping tool, you need to crimp it. So crimping is very important in the LAN. So in your networking classes, Mubin sir will take a crimping lab, how to do the crimping and all. You will do that. So if you do the crimping, but nowadays um, you have an option. You can just go and purchase directly. I want 1 meter LAN cable. So both side it will be crimped. It will be attached. You just go and plug and play. That's it. You no need to do the crimping. You 1 meter, 2 meter, 3 meter colors, various colors of the cable, brown, red cable you can use for the critical connectivity, blue cable, gray cable. So many things are available. It depend on the organization. Okay, how much they want to spend and how much. So, but still the crimping is important. But you need to learn the crimping. So crimping is one of the lab in the cabling we need to understand. Then we have a fiber optic cable. Okay, before leaving um, the class for today, um, ask admin and Hassan to show the fiber cable. So there are fiber cable and the LAN cable is are available there. You can go and see that how they look like. Okay, that's only the tomorrow if you go to interview, someone show you this is the LAN cable and this is the fiber cable. So you should be understand. Okay, this is the fiber cable. I know, I saw that, right? So fiber, the data will go into the form of light here in the fiber cable. Okay, and this fiber cable, and this is called a SFP. SFP is used, and this SFP will connect to the switch. So fiber cable is used for the longer distance. Okay, generally we use it for trunking. What is the trunking? That is a switching topic. We'll see that later. Okay, so now fiber cable, and now in the LAN, so unshielded twisted pairs, so there are categories: cat 1, cat 2, cat 3, as I said, right? So cat 6 is currently supporting 100 meter, 10 gigabit to the 55 meter. So it support 100 meter and 1 gig to 10 gig. And the cat 7 is a fresh copper cable pattern, can support 10 gig to the length of up to 100 meter. So it depend on cat 5, as I said, cat 5 and cat 6 and cat 7. So currently cat 6 is running into the market because it support 1 gig. Because as I said, if you choose a cat 7, so you need to have both end 10 gig connectivity. Your switch port will be 10 gig, your laptop port should be 10 gig. Then only you can use the cat 6. So that will be very costly. But you should have understanding. But we are using the cat 6. So these copper cable are cat 6. And this is how you do the crimping, right? You connect to the LAN. That's it. If you know this much information about the cabling, that is more than enough. Okay. Because you should understand the cable type, copper and the fiber, SFP, and the how the copper crimping and all. That is more than enough, because that is only we use in the LAN, into the LAN. Okay. Now just a high level. So that is layer 1. Layer 1, there is nothing in the layer 1. Okay. Layer 1 is all the physical connectivity. And if you remember, recall our previous lecture, so in the layer 1 we have all the data center. Data center is all about the layer 1 connectivity. Data center, what is data center? Data center is uh, a separate, a secure environment or secure location in your office where all the network equipment will be put it into the rack. That data center will be highly only authorized people will access to that data center. It will be having a high cooling environment, because the every device they generate a lot of heat. The devices, the server, your switches, firewalls, routers, database servers, your load balancers, all the your equipments will be put it into data center, and in the data center the racks will be there where all these devices will be put. So that connectivity, copper cable connecting here and the fiber cable will use there. So this is important. racking, stacking, cabling, labeling. Every cable should be labeled with the name and all. So these are the information which are no technology will involve there, but you should aware about that. That in the data center, all physical connectivity will be there. Okay, so that is one thing. Now coming back to that broadcast, and also this is types of communication like unicast. Unicast is something if one machine is connecting to another machine, one IP to another IP, so this is unicast communication. Broadcast means like one machine, if it send information, so it will go to the all machines. That is called a broadcast. And the multicast is one machine is especially talking to some special machine. That is called multicast. Unicast, broadcast, and the multicast, three types of communication in our network. Okay, with that. So layer one is done. Only one lab, two labs are there. So I can say, yeah, means how to build a LAN. Okay, that you will do in the packet tracer. The next thing is a crimping. That lab you will see. The third thing is you should have awareness before leaving to the class. Just have a look on the fiber cable and the copper cable, how they look like, look and feel, and have a look on the rack, how the have a look on the switches physically. In our lab we have switches and firewall routers there. Just have a look on that physically, how it look like. That's it. So now switch. So coming back to this ones, because we are not going to start the switch today. Switch will start tomorrow. But this is just a base of yesterday's class. Like switches. Switch, it does a switching, right? Forwarding of packet from one switch port to another port, right? There are two types: unmanageable switch and manageable switch. So unmanageable is plug and play. Manageable switch has a brain, right? So what is switch? Switch are the layer 2 device work on data link layer. Switches learn the MAC address, which is called a physical address. Switches are intelligent device. They maintain a CAM table, content address table, content addressable memory. Switch does a switching. What is switching? Forwarding of frame from one port to another port. See, if your one machine is connected here, another machine is connected here, and they are the switch will do a switching, forwarding of frame from one port to another port. That is switching. So how it does? There is a separate technology there are in the switching that we are going to learn soon. Similarly, the MAC address which learned by switch. So MAC address is a 48 bit MAC address. Can you see the first 24 bit will be organizational unit identifier. This first part will be organized like Dell laptop. They will all will have a similar, but the network interface control this part will be unique. Every MAC address in the world will be unique to each other. Okay, the first half will be the organization like Cisco device. This will be the common, right? See, here is one example. Can you see 0050? This is the common. 799 also common. But can you see here it is changed? 1, 2, 3. Okay. So MAC address is a 48-bit physical address. You will never ever change. It will build by the manufacturer company, right? And how to see the MAC address? ipconfig space hyphen slash all. Done. IP address. See, IP address is a very big topic. There are books written on that. And in our class, like in the last, there is something called subnetting that will be detail about this IP address and all that will be different. But now for today, we will just talk about few high level IP address. So IP address, it is a logical address. There are two version, IPv4 and IPv6. IPv4 is 32-bit, IPv6 is 128-bit. Both are used, but most commonly used is IPv4. Okay, who own this number? Actually, the Internet Assign Number Authority, IANA. This is the organization. They are the owner of this IP addresses. Okay, so how the IP address look like? See, 192.168.100.1. See, actually, this is a decimal format. But if you actually the IP address will be something like this: 11000000 dot 1010 dot 00010 something. So it look like your exam marks, right? Yeah, this is the first test 1 1, then 0000, then fail, then 110000. So these are decimal because computer understand only 1 and 0. And when you convert this to the decimal, so it look like 192.168 second octet. So 8 bit, 8 bit, 8 bit, 8 bit, like this, 32 bit. Okay. IP address divide into 5 classes: class A, class B, class C, class D, class E. Class A, the first octet 1 to 127, class A. Second octet, the first octet start from 128 to 191. The IP address will be class B. If the IP address start from 192 to 223, between 223, then it will call a class C IP address. Class D and E, they are used for the future use and the multicast. So in a world, only class A, B, and C, 3 classes are used. Remember this one. Next, in IP address, again, there are 2 categories. Now see, there are 2 versions, IPv6 and IPv4. In IPv4, again, two classifications: private IP address, public IP address. What is that difference? Private IP address used in a LAN. It is not recognized on the internet, assigned by a LAN administrator, unique only in the LAN, free of charge. And the private IP addresses range are 10, 10.0.0 to this one, class B 172, and class C this. So only these IP addresses are free. Remember, these IP addresses are free only. Rest all IP addresses in the world is a public, called a public IP address. Private IP address and public IP address. Public IP address, the word you see, the public means it is cost. Private IP addresses are free, public IP addresses are the cost. Okay, who manage this? IENA. So IENA, given that, okay, these are the IP addresses, you can use it for the free. So we will, in every organization, in the offices, we use these 3 classes only: class A, class B, class C, and this ranges only. IP address start from 10, IP address start from 172, IP address start from 192. If any IP address start from any number, 193 means public, 177 means public, 9.8.8. something public. Only the first, look at the first octet and you can understand the IP address is private or public. Okay, and you can see, and these private IP addresses are not allowed on the internet. Okay, there is a rule. Why? Because these are the free charge, so you need to purchase a public IP address. Okay, so how to see the IP address? ipconfig / all, you can see that. Okay, now that is enough for now, because for the understanding switching, we don't require much understanding of IP address. Okay, IP address will more use into the network layer, and to the firewall, and the subnetting will come into picture in the WAN side. Okay, but for the learning the switching technology, you don't want to become understand the IP address or not. So that we will see in the last. Okay, but now coming back to the host versus network. What is host? Every single machine will call a host. See, and a group of machine will call a network. So can you see 192.168.55.0 is network, 192.168.55.253, 192.155. With the same number, so this is called a host. Host IP address, network address. Host IP address, network address. Okay, so these are 2 terminology. So now again a little bit, sorry, a little bit more about the IP address. Class A, class B, class C. I will share this PPT with you. You can just have a look and try to understand. Like class A will any IP address start from 1 to 126. Then this, and the first, look at the first octet, the private ranges, and the private IP address, their subnet mask are 255. If you are using class A address, 255.0.0.0. Class B 255.255.0.0, and class C 255.255.250. So 255 represent a network bit, and H represent 0 represent the host bit. Okay, network bit and the host bit. Host bit, network bit cannot change. Host bit can be changed. Okay, that remember one thing. So this is our IP address. So now we understand the 2 important addresses in the networking: MAC address and the IP address versus MAC address versus IP address. So now we remember, now we understand that if this machine want to talk to this server, both need to understand their MAC address and the IP address. Okay, so if suppose this machine is want to talk to the server and you just know the IP address, so it will go to the switch, and switch will do the ARP request, and it will find the MAC address. Then the communication will be happen. Okay, the MAC address is the um, unique identifier assigned to the NIC. It is a standard. It cannot be changed. It assigned by the manufacturer company, cannot be changed. 48-bit work at the data link. IP address, numerical number stand on the internet address. Logical address help identify connection device assigned by administrator or ISP can be changed. 32-bit and 128 two bits are there. Work in the network layer. See, understand physical layer, data link layer, and the network layer. How the difference is, what are the devices? Just try to have a broader picture on that. MAC address and the IP address. These are the two your bread and butter in the networking. Okay, that's the first thing for the troubleshooting. Okay, next, what is ARP? This will be the last slide, last slide. So generally, if you know only the IP address and you want to know the MAC address, so ARP request will be run. Okay, and that is, so it will go and it will get the MAC address. And the similarly REARP, reverse address resolution protocol, when you know the MAC address and you want to get the IP address, so a reverse ARP will be happening. So this will happen automatically. So you just need to understand that how IP get a MAC address by using the ARP, address resolution protocol, and how MAC get IP address by using the REARP operation. So these are the two protocols used. So these are the three main commands you need to remember. Ping command, we already saw that ping command. Similarly, we have a traceroute command and nslookup command. So how to see that, I will show that. So yeah, so this will be my last slide for today, and yeah, um, we will see that traceroute and nslookup command, and also I will show you public and private IP address, how to see that in your machine. Okay, so 5 things you need to do today. And yesterday we talked about why we are learning Cisco only, because this is just an old chart, but you can see the like most many it is acquiring more of the um, market is based on the Cisco switches and router, especially in the switches and router. That's why if you learn this, you will have a more opportunity. But no one can stop you to learn the Barracuda, Juniper, HP. It is a learning this one. It's a different hardware. Some changes will be in there in the CLI command, but it will be good always. But that's why we are learning a Cisco and how to connect Cisco and all that. This tomorrow we will go how to start the switch. So this slide we will see tomorrow. Okay, so now this is the end. I will just stop here and I will show you the another two commands. So now see, this is my laptop. I'm going to go for the CMD. Just go to the CMD. Everyone, remember, everyone has to do this today. What you need to do is, first, I'm in my laptop, I'm going to say ipconfig space slash all. Just put this, and now you can understand what you have. So can you see this in our wireless? Now see, this is the MAC address, physical address, and this is an IP address. We got it right. MAC address, IP address. So we understand this. Ping we already know. Then then we have a tracert. Tracert command you will understand later. Just try to ping any public IP. So you will find how it is going, like hop by hop. It will how you are able to reach to that particular destination. It will tell you that. So in the networking, in the especially in the routing, you will it will be very benefit that traceout command will help you there. Okay. So I will just close this. Okay. Similarly, nslookup, because this command we are going to use in our day-to-day life. Will It is not a for last time we are using. And let's say nslookup google.com. So can you see? So the google.com is a DNS name, domain name service, that you understand. But actual IP address of the Google is this one, right? So this is IPv4, this is IPv6. So they use this one. So when I say I want to see your private IP address of the machine, so I can just put the command and I can say my private IP address is 192.168.1.161. See, 192 means private IP address. But if I ask you what is your public IP address, so what you need to do, just go to the Google, and just search here what is my public IP. Just hit this and you will come to know. Can you see 103.48 something? So this is your public. Can you see 103 means public IP address? Private IP address, public IP address. So this is how you will understand this one, private IP, public IP. So guys, that's it for today. So a lot of things today you learn. So especially you need to have a look on the copper and physical cable, then do the ping, create the LAN on the packet tracer, get the install packet tracer, ping trace, just try to do that and identify the private IP address, MAC address of your machine, also public IP address. These are the assignment for you. So it will connect you tomorrow, mostly offline in the class. So I will meet you soon. So I'm going to stop here. And yeah, that's it for today. So I will update in the group tomorrow timing. And let's see there. So